with the Georgia Standards of Excellence titled 8.GSR.8, and it is Solve Contextual Geometric Problems Involving the Pythagorean Theorem and the Volume of Geometric Figures to Explain Real Phenomena. This video will specifically focus on the part of the standard that says Solve Contextual Geometric Problems Involving the Pythagorean Theorem. So, class, let's think back on what we have previously learned. I know in previous years your math teachers have talked about acute and obtuse triangles. An acute triangle is classified as an acute triangle if all three angles are less than 90 degrees. So in this diagram here, we see that angle A is less than 90 degrees, angle B is less than 90 degrees, and angle C is less than 90 degrees. An obtuse triangle is classified as an obtuse triangle if only one angle is greater than 90 degrees. So here in this diagram, we can see that angle B is greater than 90 degrees. For both an acute and an obtuse triangle, all three angles must add up to 180 degrees. Our focus for today will be specifically on the right triangle. So a right triangle is classified as a right triangle if one angle is equal to 90 degrees. So in this diagram here, we can see that angle B is equal to 90 degrees. While you're watching this video, I want you to look at your surroundings and see if you can find any examples of right triangles. I know in our classroom we have the American flag displayed, and if we were to cut the flag in half diagonally, we would be able to form two right triangles. The calendar on my desk could also be cut in half, and we would have two right triangles. And then also, if you look at the squares inside of the triangle, if we were to cut those in half, we would have two right triangles. Once you have found an example of a right triangle in your room, I want you to think about this question. If I gave you the measurements for two of the sides on your right triangle, how would you find the third side? Finding the missing side length is different than finding a missing angle because side lengths for triangles can be as small or as large as humanly possible. You can have a side length of 2 centimeters or you can have a side length of 100 centimeters. For missing angles, if you already have two of the angles, you know that the third one has to help you equal 180 degrees. So for finding a missing side length, it does not have to fit a specific criteria, while missing angles do have to fit a specific criteria. You would be able to find the third side by using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. And on the worksheet that I gave you to use alongside this video, I have written it on there. This theorem will also be given to you on your end of year exams. On the screen, I have a diagram of a right triangle, and as you can see, the C in the Pythagorean theorem will always be the hypotenuse of the right triangle. A and B are known as the legs of the right triangle. So if you are given sides A and C, you'll be looking for side B. If you are given sides C and B, you will be looking for A. And then if you are given sides A and B, you will be looking for C. On your worksheet, you will see this problem. I want you to pause the video and then unpause it once you have finished trying to figure out the answer by yourself. So go ahead, pause the video, and get a pencil and start trying to figure out this example using the Pythagorean theorem. Once you have unpaused the video, I want us to face the facts. In this problem, we are trying to find the length of the hypotenuse. We do not know what C is. We have already been given the lengths for both side A and side B. And as we can see, side A is 7 inches long, while side B is 5 inches long. On the screen, I have my work displayed. So what I did by plugging into the Pythagorean theorem, I did 7 inches squared plus 5 inches squared equals c inches squared. This is what we're trying to find. We are trying to find c by itself. So 7 times 7 equals 49, and then 5 times 5 equals 25. You can see here I did not include the inches, but that does not mean that they are not relevant anymore. Inches are units of measurements, and we will plug them in at the very end. So then we get 49 plus 25 equals c squared, and 49 plus 25 equals 74. So then we do 74 equals c squared, and we are trying to get c by itself. So we would have to find the square root of 74, and when I plugged it into the calculator, it did not equal a nice number, so I just left it that way. So my answer was square root 74 inches equals c. And then at the very bottom, I drew a diagram of my right triangle, and I did 7 inches, 5 inches, and then square root 74 inches. I highly recommend you guys making diagrams of a right triangle to help you put everything into perspective. And I hope you also got the same answer as I did. And if you didn't, there is one other practice problem on your worksheet that I want you to work on by yourself. You will see that you are trying to find side A.